All right, welcome back. After a long break, hope you're well rested. Hope everything is good. I got some stuff in my ears here. All right. So, today we're going to continue on in geometry. Unit 1, Lesson 17a. There was some mix up in the numbering here. Was it 17a? And your learning target for the day is I can use algebraic problem solving to find missing angle measures given sufficient information. Just like yesterday, we're trying to find missing angle measures in problems. We have to use our geometry brains to rationally figure things out, to think logically, to map things out, and then we have to use our algebra problem solving skills to then find out what the value of x is. And then sometimes we then need to plug x in something else to find what we're looking for. Some more definitions as we are wrapping up Unit 1, trying to break down all our geometry definitions. And I have a technical little explanation of what an angle is. Remember, whenever two straight things intersect, we're going to get an angle. It could be a ray, it could be a line, it could be a line segment. If they intersect, they intersect at a particular angle. Well, the measure of the angle, how the measure of the angle is the measure of rotation to map one straight thing onto the other. That makes up that angle. We do that in degrees. There are 360 degrees in a circle. There are 180 degrees in a straight line. That's half a circle. If you think about half a circle being a straight line, the diameter of a circle. And 90 degrees is going to be a right angle, 90 degrees, right? It's going to be perpendicular. 90 degrees, perpendicular, right angle. And let's do some of our definitions we got here. The one definition we have here is acute. So you can be, oh, that's an acute angle. Well, yeah, so an acute angle comes from the Greek or the Latin. It's Latin for meaning sharp. So when we think of an acute angle, oh, that's an acute angle. You're looking at something that's going to be sharp. It could be really, really sharp, or it could be up to 90 degrees. It has to be less than 90 degrees or more than 0 degrees. But anywhere between 0 and 90, that's going to be an acute angle, something that's sharp. When you think acute, think sharp. Obtuse. When you think obtuse, think dull. It's not an angle that looks like it's going to cut anything. This is going to be an obtuse angle. An obtuse angle has an angle measured between 90, so it's going to be a little over 90, up to 180 degrees. Up to 180 degrees can be all the obtuse angles. So 120 is between 90 and 180. 170, 91. All these are obtuse angles, not sharp. Think dull. Right angles. I just talked about those a moment ago. Right angles are so important. They're the most important angle measure in mathematics because it means two lines are completely independent of each other. This one's going this way. This one's hitting it perpendicularly. Creates a 90-degree angle, which is the corner of a square. The corner of a square is a 90-degree angle, a right angle. A square has four 90-degree angles. And we're going to be looking at the right angle a lot. We use the right angle for a lot of things, especially for trigonometry, which we'll get into. And what else do we use right angles for? Gosh, for Pythagorean theorem, all sorts of things. That right angle comes in handy, okay? And then here we have a straight angle. A straight angle has a measure of 180 degrees. So as I said, a line, a half circle, has a measure of 180 degrees. So a line has a straight angle has a measure of 180 degrees. Reflex. A reflex angle is anything more than 180 degrees to a full circle, so 360. So if something like, I'll show you. So let me show you here on the example. I have some examples here. Let's talk about these. Let's talk about these right here. What does this angle look to you? Is that more or less than 90? We've done some practice with this. More or less than 90. We use our protractors. I'm looking at that and saying, oh, that's more than 90. 90 would be somewhere here. More than 90, past 90, but it's not 180 degrees. It's not a straight line yet. So this is going to be dull. This is going to be obtuse. That's going to be an obtuse angle. This one here, oh, okay. We were just talking about these. This little arc mark means we're looking at the outside piece of this angle. Not this. This would be obtuse angle over here. Inside here, that's obtuse. But this thing that's beyond obtuse, it's like beyond a straight line. Beyond a straight line, that's going to be called a reflex angle. Reflex angle. beyond 180 degrees. And here we have our acute angles, all right? Is that sharp edge, like the edge of a knife, an acute angle. What do you think this one is here? On a line, it's straight. Yes, indeed, it's a straight angle. And this one here, what does that look like to you? Now, if you said obtuse or if you said acute, that's okay. You could, I mean, this is a right angle. It is 90 degrees. It is 90 degrees. It's a right angle. And it's really close to being an acute, and it's really close to being obtuse. So if you guessed any one of those, you're really close to being right. Just make sure you know that right where obtuse and acute butt up against each other, that's a right angle, right? If it's less than 90, it's going to be acute. If it's more than 90, it's going to be either obtuse or reflex or straight. And that 90 is right in there. That's our important one. All right, moving on. So here is our exploration today. And I set these up a lot. I've been trying to set these up more and more like Regents questions. So we basically in class are having something that at least feels like Regents questions, so we get that practice in. So I give these instructions, kind of sounding like a test, preparation company. Find the measure of each of the following angles. Unless otherwise stated, we will always assume we are measuring a non-reflex angle and classify it as an acute sharp, obtuse dull, or right. Name the angle using a 3-letter combination. So find the measure of each angle. I was gonna say I embarrassingly don't have a protractor here, but no, I have a protractor here. Hold on a minute, it's right over here. I have a nice small protractor that'll be coming real handy for this. Actually, a small protractor is kind of nice because you don't always have to extend your angles, so it saves you that step. But the smaller the protractor, the less accurate it is. So here I go. If you can see here, I'm lining my protractor up so this point right here matches that point right there, and that this line here lines up nicely along there. So I'm putting it down, lining it up. And so when I get this on here, I'm looking at this and I have to read it. This protractor is telling me this angle here is either 70 or 110. It's either 70 or 110. Now this is obviously more than 90. So when I interpret my protractor, there's 90 right there. That would be 90. When I interpret my protractor, I'm going to say that's 110 degrees. So I'm going to say angle PVM is equal to, actually I'm going to put the M of angle PVM is 110 degrees. So let me show you and explain why I wrote that. This M, remember, is the symbol for measure. When you see it in text on a computer, it'll be in italics. It'll be a little slanted. So it's the measure of angle. That's our angle symbol. PVM. And remember, the vertex, the point where the two lines meet, always has to be your middle letter. I could have called this MVT. That would have been fine. Or I can call it TVM, but the V always has to be in the middle. I could not call it PMV. Doesn't work. All right? I'm going to say it's equal to 110 degrees. I have measured this angle PVM, equal 110 degrees. All right, let me do the next one. I'm looking at this, I'm saying it looks like this leg's a little longer, so I'm actually going to flip my paper upside down for a second as I measure this. Lining everything up. Oh, do you see that? Do you see that? It lines right up on 90 degrees. This is a right angle. This is a right angle, all right? Let me turn my paper right side up again. Here we go. I'm going to this time I'm going to make the angle, this little symbol here, I'm going to make it have a hard edge. Normally, I would do this like a little arc mark. It's a nice smooth arc mark to say it's an angle measure. But when I know it's 90, when I know it's a right angle, I'm going to make a nice little corner of a square, 90 degrees, all right? So I'm going to say angle Oop, let me put my M in there. The measure, because I'm measuring. The measure of U-O-Y. U-O-Y is equal to 90 degrees. And I could have just as easily have said it's the measure of angle YOU, which would be U. Either one works. Just because that's equal to 90. Again, just as long as the O, the vertex, is in the middle, we're good. I keep looking out the window. There's some beautiful birds out there right now feeding at my bird feeder. Some nuthatches and some woodpeckers and cardinals, and I get distracted sometimes. All right. There we go. So if you can see what I'm doing there, I'm lining this up real nice. All right. That matches that on the vertex. I'm reading it over. This is either 50 degrees or it's 130 degrees. Well, as we look at this, hopefully you recognize this is an acute angle. And this is far less than 90 degrees. That would be a 90-degree angle there. Let's get to that. This is way less than 90. This is going to be 50, right? 50 degrees. So the measure of angle CAT, cat. The measure of angle CAT is equal to, oop, I almost wrote 90. Nope, 50 degrees we said. Equal to 50 degrees. That's how this is done. Very good. How do you feel about that? Give me the smiley face in the lower, smiley face reflection in the lower right-hand corner. Smiley face for this is easy. Something in between for, okay, I need a little more practice, but I'm moving along. And then frowny face for I feel confused. Help. Okay. All right. Exercise number 3. And we're trying to find those missing angles using our algebra problem-solving skills and our geometry, reasoning, and logic. All right. So given WRX, given that this is a straight line, that's what it says. This is a straight line. Solve for the value of x and find the numerical values of the measure of angle VRX, find the measure of that, and find the measure of WRV, find the measure of that. So how are we going to do this? Take a look at this. Pause the video right here. We practiced a few of these before the break. If you remember how to do these, you have to set this up in an equation. So you're thinking to yourself, as I look at this diagram, what things can I set up together as an equation? What things will be equal to what things? Part plus part equals whole. Remember that? Pause the video here, see what you can come up with. Okay, well, hopefully you came up with something. Well, we're told this is a straight line. We were told that WRX is a straight line, which means from here to here, it's half a circle, which means it's 180 degrees. Which means that it's also 180 degrees to the other side, because that would make a whole full circle, right? So the whole is 180 degrees. So the part plus part equals whole. The whole equals 180 degrees. Well, what are the two parts equal? Well, we don't know. We have these algebraic expressions. We got to figure this out. 3x plus 22, 2x minus 12, plus 2x minus 12. So here's what I'm basically saying. This plus this equals the whole line. This part, the obtuse angle, plus the acute angle, together, when I add them together, they will equal the whole line, which is 180. I know that a straight line has 180 degrees. Again, we're using that geometry brain to know that a straight line has 180 degrees. Again, we're using our geometry thinking to say part plus part equals whole. Part plus part equals whole. Part plus part equals the whole. Now we have to use our algebraic problem-solving skills to now solve for x. All right, so my first step, combine the like terms. I'm going to combine the like terms. 3x plus 2x is 5x. 22 plus negative 12. I think that's 10. But you know what? I'm going to use my tools. I'm going to trust my tools. Give me the right answer. 22 plus negative 12. Yep, that's 10. felt pretty confident about that, but I wanted you to know that it's okay to trust your tools. Let the calculator do the heavy lifting, as I always say. It's there for you on the test to help you. So now what I want to do is I want to get x by itself. I want x by itself. I want this x to get all alone. To get it all alone, I'm first going to get rid of this 10. It makes my life easier. I can get rid of the 5 right now too. I just want you to try to do it the same way every time. Especially with this problem, getting rid of this 5 times x would be pretty easy right now. But we're going to do it the same way every time, so we just become robots and we can just get this done very easily, all right? I'm letting you know there are other ways to go about it. You don't have to do it this way, but this is the way I teach it because that's just the straightforward way of going about it. Kind of boring, but it's very reliable. I'm going to cough. Hold on. I'm going to pause. All right. So why did I minus 10 over here? I minus 10 because I want to move this 10 over to the other side. And to do that, I'm going to need to, if I'm adding 10 on this side of the equation, then I have to subtract 10 to cancel it. I have to subtract 10 to be able to ignore it on this side of the equation. And equations are balance beams. So if I do something to one side of the equation, I've got to do it to the other side to make sure that the balance beam stays balanced. So if I subtract 10 here, I got to subtract 10 here. So now I have 170 equals 5x. All right. So 5 times a number will give me 170. That's what this is saying. 5. Gotta move some of my materials out of here. There we go. Now I dropped my pencil. All right. How about that? Okay. 5 times a number gives me 170. All right. I want x by itself. How do I get rid of this? 5 times x. Hopefully by now we're kind of practiced at this, and we know we need to divide by 5 to undo, cancel, multiplication of 5. So if I divide by 5, 5 divided by 5 is 1. This becomes just 1x. If I do it on this side of the equation, I've got to do it on this side of the equation. So now my x is going to end up equaling 170 divided by 5. 170 divided by 5. 34. X is 34. Oops, sorry, did I goof up my camera? There we go. X is 34. There we go. We found x. We used our algebra problem solving skills to find x. We're not done. We're not done because we haven't done this part and this part. We haven't found the measure of these two angles. But really, the upside is it's really easy to do, right? Here I go. I know that x is 34. X is 34. I know this angle measure here is 3x plus 22. So 3 times 34, I already solved for x, plus 22. That angle measure is equal to 124 degrees. Now I solve for this one. The expression is 2x minus 12. Well, I know what x is, so 2 times not x, but 34 now, minus 12. Enter, this is 56. 56 degrees. So if this was a Regents question, you would say the measure of angle VRX. VRX is equal to 56 degrees, and the measure of angle WRV is equal to 124 degrees. That's how it's done, folks. Again, give me that smiley face reflection now again. In the lower right-hand corner, tell me how this was for you, whether this needs to be, we need to slow this process down, or whether we're feeling good on this process. I'm hoping that at this point, most of you are feeling pretty good about this process. I'm thinking some of you might be in the middle right now, might be in the middle, still need more practice. But hopefully this isn't confusing for anyone. If it is, let me know. I need to know that. But guess what? You've hit your learning target, right? We've just dipped our toe in the water of our learning target. We have found missing angle measures using our algebraic skills. Hooray, hoorah. Let's do some more practice. Put my protractor away. I don't think I'll need that again. All right. Straight angles are extremely important in geometry. when two lines intersect, they form multiple 4 angles. Let's see this. Here's two straight lines, and they're intersecting. Here's one angle that's formed. Here is another angle that's formed. Here is another angle that's formed. And because I know this is going to be different, I'm going to put 2 arc marks on there. And there's a 4th angle that's formed. There I am. Actually, I want to lift this up just a little bit. I'll push it. Sorry if the camera goes out of focus. I feel like the whole paper's not on the camera. Okay. So we have our 4 angles here. In diagram below, lines GM, and FH intersect at point E. If any of the 4 angles formed is given, all other 3 can be found quickly. Fill in the table below. And so remember about what we said about vertical angles. Vertical angles are always congruent. All right? So this angle here is going to be vertical to this angle here. These 2 angles have to have the same measure, because if these are straight lines, then this plus this is 180, and this plus this is 180, which means this has to equal this, and this has to equal that, because altogether there's only 360 degrees in the whole thing. Only 360 degrees in a circle. Together these are 180, together these are 180. These 2 are going to be the same, because these are both going to be supplementary to each other. All right, let's try this. Measure of angle GEF. If I know GEF, if I know that's 120, how do I find my missing angle measures? Pause the video here, see if you can come up with anything. All right, if you've unpaused the video, hopefully you tried something. Well, hopefully you can tell me at least that angle MEH is 120, right? Because I told you these are vertical, which means they're going to equal the same measure. So hopefully you got this one. This one might be a little bit harder. These 2 angles, this one and this one, are supplementary. They're on the same line, all right? If they're on the same line, then this plus this has to equal the whole. Part plus part has to equal the whole. And the whole has to be 180 degrees because it's a straight line. Feel good about that? Straight lines are 180 degrees. This one's 120. So to find this missing piece, I take 180, the whole, I minus the part, which gives me the remaining part, right? 180 minus 120 is 60. This is going to be 60 because 60 plus 120 is 180, which is the whole thing, which is the whole angle measure of the line. If this is 60, then that has to be 60. And then I have my angle measures, 60, 60. All right, the first one's done. Now we're supposed to forget everything we just learned and do it over again, right? Now they're going to give us some other angle measures. Sorry, my camera is wiggling all over the place because I'm racing on the table. Shakes the table, shakes the camera. I'm going to cough. Now they're telling us that MEH is 150. MEH is 150. Now we are to suppose that's 150 degrees. Well, if that's 150, then this has to be 150. GEF has to be 150. If that's 150, the other has to be 150 because these are vertical angles. And same thing we did before. If this is 150, 180 minus 50, taking 180 is the whole thing, I'm subtracting 50 to find the remainder. Whoop. No, 150. So you have to subtract 150, not just plain old 50. Subtract 150 and I get 30. All right. So now this is going to be 30 degrees. Again, the diagram hasn't changed. They don't actually care about the angle measures if you measure them with your protractor. They want you to figure things out algebraically. Then this is 30. Then this is 30. Are you seeing a pattern here? I just have to find out. These are my obtuse. These are going to be my obtuse angles. These are going to be my acute angles. And this plus this always has to equal 180, right? This plus this has to be 180. This plus this has to be 180. So I can stop messing with the diagram if I can see the pattern, what's going on here. Here I have an acute angle. Find the remainder of my acute angle. I have to do 180 minus 25. 180 minus 25. 155. So I know that this is 155 degrees because that one's 25, and I need this number and this number have to add up to 180. I know that this one has to be 25 because these are vertical, and I know this one has to be 155 because these are vertical. This one over here, this is 45 here. If this is 45, then this has to be 45 because this is H-E-G, that's this one. And this is F-E-M. These two are vertical angles, so they have to be the same. If this is 45, that's 45. Ignore what I have written now. That's from our previous problem. If that's 45, that's 45. Now to find out that missing piece, I need to do 180 minus 45. 135. 135. And now that I have this part, I know that this goes over here. They're vertical and they're the same. How do we feel? Hopefully pretty good. We're 27 minutes into the video. Let's keep going. Vertical angle. So vertical angles are angles that are opposite of each other when two straight lines cross. In diagram 5, angle GEF and MEH are a pair of vertical angles, while FEM and HEG are also. So what it's saying is that these two are vertical angles and these two are vertical angles. Given the result of your calculations in number 5, this problem here, what can you say about the measure of vertical angles? Well, vertical angles are always congruent. Right? And we can see that too. If this is 135, let me show it to you a different way. Let's use our last numbers. Oh, someone just rang the doorbell. All right, so the question is like, why do we think this occurs? Why are vertical angles always congruent? Well, let's check it out. A straight line, all the angles of a straight line always have to equal 180 when we add them up. Well, check this out. That means this and this have to equal 180. 135 plus 45 equal 180. But check this out. These two are also on a straight line. So 45 plus 135 has to equal 180 again. But look, these two are both on a line. 45 and 35 are both on a line. 45 plus 35, 135, are on a line. That equals 180. And then these two here, 35 and 45, 45 plus 35, 135, also has to equal 180. So this equals 180, these two equal 180, these two equal 180, and these two equal 180, which means I know the angle measure of this one. If this is 45, I know for sure that that has to be 135. If I know this one is 135, then I know for sure that has to be 45. And if this one is 45, that means this one has to be 135 again. Vertical angles are always congruent because angle measures on a line always have to add up to 180. That's why. Pause the video here if you need more time to copy anything down. I'm going to flip the page. All right, we're on to the check for understanding. I'm going to let you, again, we're moving towards you being independent with those checks for understanding. So I'm not going to do all of this. I am going to set it up for you. Again, I'm setting these up more and more like Regents questions. So there's lots of instructions and stuff for you to have to read and think about. In the following diagram, it is known that angle EHG is the right angle. And I put that in the diagram. That little sharp corner tells us that's 90 degrees. So this whole thing, remember, is 90. I'm not going to write that. I don't want to write 90 here or there to confuse us. Just so we remember that this is 90. The measure of angle EHF is x plus 1. So the measure of this is x plus 1. And the measure of angle GHF is going to be, I'm going to put two of these here, two arc marks. It's going to be 5x plus 5. Find the value of x. So find the value of x and then find the angle measure here and the angle measure here. And mark them on your diagram. All right? So you have to think, what equation can you set up that would put these things equal to each other? Remember, part plus part equals whole. All right? You know the whole is going to equal 90 degrees. What two parts can you add together to find for x and then plug x back in and find these two angle measures? I'm going to leave it for you to do there. After you're done with this, pause the video right now if you need more time. Obviously, you're all going to need more time to work on this. Once you're done, give me that reflection. Tell me what's working for you in the classroom or on these videos. What do you need to do better? What do I need to do better? What are you doing right? What am I doing right? Maybe what you're doing right is you're getting your breakfast in the morning. You're getting the sleep you need to focus in class or to focus at home. Maybe I'm providing high quality instruction. Well, you decide. You decide. Let me know how you feel. All right, so here we go. Independent learning practice, real short. If the measure of angle A is 4x plus 12 and x is 15, is the measure of angle A acute, obtuse, or right? Explain or justify. All right. Pause the video here. Try it yourself, and then I'll go over it. Pause the video here. Don't let me just give you the answers. You writing notes doesn't help you learn. Come on. Try it. Give it a shot. Okay. Hopefully you've unpaused the video now, and I'm going to explain it. But hopefully you tried this on your own. You need to be able to do those. Okay. So it tells me that x is 15. So I'm just going to plug it in. The measure of angle A is going to equal 4 times 15. 4 times x. X is 15. 4 times 15 plus 12. I'm going to put that in my calculator. 4 times 15 plus 12 is 72. Woo! Sorry about that. Is 72 less than 90? More than 90? What is that? No, okay. Hopefully we're all yelling out, it's less than 90. So which one of these? Do you remember which one is less than 90? Write it down. Acute. 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 That's an acute angle. It's sharp. Okay? Given that angle BAM, so BAM is a right angle. Oh, it would have been a lot better, Mr. Salt, if you had thought about that before you labeled your angle. I'm going to erase all that because it says it's a right angle. So I need to approximate a right angle a little bit better than what I had. All right? Get that little corner symbol, let you know it's a right angle. If measure of angle BAM is 4x plus 22, then solve for the remaining value of x. All right, so we need an equation now. We need to use our geometry knowledge to set up an algebraic equation. Geometry knowledge. How many degrees are in a right angle? 90. There are 90 degrees in a right angle. We know this whole thing is equal to 90. which we also know that the whole thing equals 4x plus 22. We're going to use up now. We've used our geometry brains to set up the equation. Back in Algebra 1, you were just given the equations. Now you have to come up with the equations on your own. That next level thinking. I'm going to minus 22 on this side, right? That cancels that positive 22 over there. I'm minusing 22 over here. That gives me 8. That gives me 68. 4x equals 68. Let me take 68 and divide by 4. There's 1. 1 times 4 is 4. That's drop 6 minus 4 is 2. Dropping down the 8. 4 times 7 is 28. 17 equals x. So when I divide by 4 on both sides, I get x equals 17. Did it ask for anything else? No. Right there, I'm done. It told me to solve for the value of x. So there we go. X equals 17. I divide by 4 on both sides. That gets rid of the 4 here. 68 divided by 4. 68 divided by 4. 4 goes into 6 once. 1 times 4 is 4. 6 minus 4 is 2. Drop down the 8. 28. 4 goes in 28 7 times. 7 times 4 is 28. There's no remainder. The equation's done. X equals 17. Have a wonderful day.